Hello everyone, what's up? Hope you all are doing good and welcome back to my world of physics. Today we are going to do a quick revision on numericals of chapter the electricity. We are going to solve the previous year questions with which a quick revision of all the concepts will be done. So stay tuned till the very end and hope this will be beneficial for your exam tomorrow. Now on the screen you can see the previous year questions like last year questions asked from the chapter electricity. So I have covered almost five sets having three sets each, means 31/1/1 is number one set. Similarly, there are three sets for 31/1. Then we'll go to 31/2. For that 2 we'll have 3. Like that I've covered 5 sets and maximum of the questions asked I've covered it up. So question number 1, which is for 2 marks, goes like, how would you connect the 3 resistors of 6 ohms so that their total combination becomes 9 ohms, and also justify your answer. So previously we checked whether by connecting them in series or parallel is it possible. So you all can see if we connect them in series we get only 18 ohms, and like if we connect them in parallel we get 3 ohms. So just a plain series or parallel combination can't be done. So a mix of series and parallel has to be done. So you all know parallel combination reduces the resistance. So I tried connecting two 6 ohms resistance in parallel. So once you connect two 6 ohms resistance in parallel, you get the effective resistance as 3 ohms, and then 3 plus 6 gives you 9 ohms. So this is how the connection has to be made. And this is your 2 mark questions asked in the previous year. Now, similarly, if we go down, there was an option for this 2 mark question. You can either solve that, or this was the second option in which you had to calculate the power consumed. So a circuit was given having a 2 ohm and a 1 ohm resistance and 6 voltage of potential difference. So to calculate the power, everyone, we know power's formula will be I square R if we have resistance and current. So first I'll have to find out the current. So what we did, we calculated the resistance in series, that is 3 ohms, and then the total potential difference, that was 6 volt. So by applying Ohm's law, we got the answer as 2 ampere, and then we substituted in the formula I square R. So I square 2 square into R, that is 2. So 4 into 2, that is 8 watts. This was the 2 mark option. So out of these two you can solve any one and secure your 2 marks. Now moving ahead to the next question. So next question from the same paper, we have 5 mark question. So these are the two questions asked, and like the first question says define electric power, express it in terms of potential difference V and R. So power formula which contains potential difference and resistance, and we have to define power. And next was the numerical, and next is the resistivity equation. We have to derive the unit of resistivity, then the sum of resistivity, okay, and how the electrical resistivity can be affected if the wire is stretched or if its length is doubled, and we have to justify the answer. So whatever topic you are comfortable with, if you're comfortable with power, you can solve first sum, and if you're comfortable with resistivity, you can solve the next sum. So this will have to gauge in the start of the paper. Like when you get reading time, you have to just shortlist the questions which you are going to solve. तो आपको इस तरीके से पहले क्वेश्चन रीडिंग टाइम में पढ़कर शॉर्टलिस्ट करना पड़ेगा कि आपको पावर का सम अच्छे से आएगा, पावर का क्वेश्चन करे 5 मार्क्स का, या फिर रेजिस्टिविटी का क्वेश्चन करे 5 मार्क्स का। तो जिसमें आपको कॉन्फिडेंस है मैक्सिमम मार्क्स लाने का, वो अटेम्प्ट करो। ये पॉइंट आप दिमाग में रखो हर एक क्वेश्चन के लिए। रीडिंग टाइम में आपको सबसे पहले एनालाइज करना है कि कौन से क्वेश्चंस कम टाइम कंज्यूमिंग है एंड आप इजीली सॉल्व कर सकते हो, एंड वही क्वेश्चंस आपको एग्जाम में सॉल्व करने हैं। सो फर्स्ट क्वेश्चन का सोल्यूशन। फर्स्ट क्वेश्चन में हमें पूछा है डिफाइन इलेक्ट्रिक पावर। सो the rate at which electrical energy is dissipated or consumed in an electric circuit is termed as electric power. And power का formula पूछा था with reference to potential difference and resistance. So we all know power is V square upon R. Perfect. So ये first solution. Then हमें power calculate करना था। तो वी ऑल नो पावर का फॉर्मूला इज एनर्जी अपॉन टाइम। हमें दिया गया था एनर्जी एज 11 किलोवाट आवर। सो यू कैन सी एनर्जी गिवन 11 यूनिट्स मतलब 11 किलोवाट आवर, एंड पोटेंशियल डिफरेंस was given to you just to use in the next sum, not over here. Now energy 11 kilowatt hour and time given was 5 hours. So power is energy upon time because energy is power into time. So power will be energy upon time, 11 upon 5, that is 2.2 kilowatts. So you can write your answer 2.2 kilowatt or 2200 watts, like multiplying k, 1000 multiplying instead of k. Then आगे जाते हैं तो हमें नेक्स्ट बताया गया है कि कैलकुलेट द करंट ड्रॉन बाय द ओवन। सो current I will be P upon V. So just now we calculated the power that was 2.2 kilowatt. तो उसे हमने like 2.2 kilowatt, now we have converted it into watt. So 2200 watts upon 220, it gives us the value of current, that is 10 ampere. Similarly, moving ahead, last question they had asked was about the resistance. So resistance R is equal to V by I, 220 upon current which was 10 ampere. So 0 gets cancelled and we get the value as 22 ohms. So these were the two questions. Like then the second part of resistivity. Write the relation between resistance R and electrical resistivity rho. So in short, after reading the entire question, you will understand they have just asked you the formula for R in terms of resistivity. So we know R is rho L upon A. So how to calculate rho? So rho will be RA upon L. Why we are doing this? To derive the SI unit of rho. That is, derive the SI unit of resistivity. So rho is RA by L. Now in place of rho, like in place of R, I will place ohm. In place of area, I am placing meter square, and in place of length, I am placing meter. So 1 meter from the bottom will get cancelled out with the meter square, and we are left with ohm meter, which is SI unit of resistivity. So our first question is solved. Moving to the next questions, where they have given length as 3 meter, resistance as 60 ohms, and area they have given us directly as 4 into 10 raised to power minus 7 meter square. Now I think this is clear. Yes. So rho will be RA by L. Now we are just substituting R 60, A 4 into 10 to the power minus 7, the whole thing divided by length 3 meters. So we'll have to solve it more, like we'll have to substitute the values, like 60 by 3 we get 20. So 20 into 4 into 10 to the power minus 7. So that is 80 into 10 to the power minus 7. I'll just move the decimal. So it becomes 8 into 10 to the power minus 6 ohm meter. I hope you find this useful. And then last question which they had asked, how would electrical resistivity be affected if the wire of part 2, means the wire which we have calculated in part 2, is stretched to its length doubled? justify your answer. Now, as we saw that rho is RA by L, but they are asking what will happen to the rho. So rho remains the same. Why? Because rho is a characteristic property as we have talked about in the concept video, and it is not affected by the change in dimension. As the material of the wire is same, वायर का मटेरियल सेम है, सेम वायर, तो उसका रेजिस्टिविटी भी सेम रहेगा, सो रो का वैल्यू चेंज नहीं होगा. सो इस तरीके से हमारे तीनों क्वेश्चंस आंसर हो जाते हैं, जिससे हमारे 5 मार्क्स सिक्योर हो जाते हैं. नाउ मूविंग अहेड इज द सेकंड सेट. So here the questions which are different, I'm catering only those questions. Like the same questions were also there. Like out of the 3 sets, maximum of the questions are same. Like 5 mark question remains the same. MCQ sometimes it changes, and 2 marks like the sequence changes, and the 2 mark question the value changes. Now in the second set, they instead of giving you 2 mark, they had given you 3 mark question also. So the 3 mark question goes like, name 2 safety measures commonly used in electrical circuit and appliance, and then the numerical of power. So 2 safety measures are electrical fuse and circuit breakers or earthing. तो इन तीनों में से आप कोई भी 2 लिख सकते हो, एंड दोनों के बारे में 2 lines you have to write. So which will secure your 1.5 marks or 1 mark, whatever markings they have given. So because they might give you this for 1 mark and the numerical for 2 marks, or they can give equal 1.5 marks for both of them. Now moving ahead to the numerical, you can see power rating of electric oven is given, and like potential difference is given. So potential difference is 220 volt and power is 2 kilowatt. So first what I do is convert that kilowatt into watt. Now many of the students ask, so when to convert and when not to. Like if they ask you total energy consumed या टोटल एनर्जी यूज्ड, अगर उन्होंने क्वेश्चन में एनर्जी के बारे में पूछा, एनर्जी कंज्यूम कितना हुआ या एनर्जी यूज कितना हुआ, तो यू हैव टू यूज कमर्शियल यूनिट, एंड कमर्शियल यूनिट में द पावर हैज टू बी इन किलोवाट and the time has to be in hours. So if it is already given, no need to convert. But if it is not given, you'll have to convert. So the word which you have to find is energy consumed or energy used. जैसे इस क्वेश्चन में they are not talking about energy. So there is like no need to keep the unit in kilowatt. So we will have to convert it into watts. Moving ahead, everyone. Next, the sum says minimum resistance and maximum resistance. So first of all, you have to be familiar that minimum resistance is when they are connected in parallel, and maximum is when they are connected in series. Correct. As you have to increase the resistance, we connect them in series, and if you have to decrease the resistance, we connect them in parallel. So if they are connected in series, the total resistance becomes 48 ohms, and then by calculating power by V square upon R, we get power as 0.75 watt. And if you connect them in parallel, similarly we have connected and calculated resistance in parallel, RP, it becomes 12 ohms and the power becomes 3 watt. So you can see power in parallel is 3 watt, whereas power in series is 0.75 watt. Now the ratio of power they have asked, so dividing power in parallel upon power in series, we get 3 upon 0.75, which is nothing but 4. So sometimes students find difficulty in solving this decimal. So what I've done is I've removed the decimal So after decimal there are two digits, so I have put two zeros at the top, so it becomes 300 upon 75, and this is easy to calculate, that becomes 4. So the ratio is 4, and this ends a 5-mark question from this set. Now we are moving to the new set, that is 31/2/1. So this is the second set the same year, and over here we had two MCQs also. In the previous set the MCQs were not from electricity, but in this set these MCQs are from chapter electricity. So first MCQ, the maximum resistance of the network of 5 identical resistors of 1 upon 5. Now maximum resistance is when they are connected in series. So one resistor is of 1.5. So what will happen if you connect 5 of them? I will just have to multiply by 5. 5 gets cancelled. The total resistance becomes 1 ohm. Similarly, next one, the IV graph is given for the resistors of resistance R1, R2, R3, and select the correct statement from the following. Now, for this, you have to be familiar with Ohm's law. Ohm's law says V is equal to IR. Now, R will be V upon I. R is V upon I. Matlab, resistance is V upon I. Resistance is directly proportional to potential difference, whereas inversely proportional to current. So, here you can see for R1, current is maximum, and for R1 V is minimum, whereas for R3 V is maximum and current is minimum. So from here I can say that R value is more in third case. R3 is greater than R2 is greater than R1. So our answer is point C. So remember, more the current, less is the resistance, because they are inversely proportional. Or you can also remember, more potential difference, more is the resistance, because they are directly proportional. So R3 is the greatest, and we can find it only in option C. So our option C is the correct answer. Now moving ahead for 2-mark question. So it says use Ohm's law to determine the potential difference across 3 ohm resistor in the circuit shown in the following diagram when key is closed. So we have to calculate the resistance potential, sorry. So we have to calculate the potential difference across 3 ohm resistors in the circuit. So I will be V upon R, as they are connected in series. I am saying V upon R S. Adding them, 3 plus 2 plus 1 gives me 6. So 6 ohms is the total resistance. Applying Ohm's law, I get V ka value as 1 volt. Simple 2-mark question. Then moving to the next set of the set number 2, 31/2/2. In this they have asked us the SI unit of resistivity. Straightforward question. Ohm meter is the answer, option C. Next, see, the question is almost similar to previous set, but the values are different. Now here they have asked minimum resistance which can be made using 5 resistors each of 1 ohm. So minimum each of 10 ohm, sorry. So minimum is when the resistances are in parallel. So we will be applying, yes, resistance in parallel formula. So 1 upon R1 plus 1 upon R2 till R5. So it is 5 by 10, and the resistance 1 by Rp becomes 1 by 2. So Rp becomes 2 ohms, that is option C. Now in the same set we have the 4-mark question. So this 4-mark question goes like this. Now in this you all can see the first one mark question is compulsory, whereas there is an option for 2 mark question. You can solve any one of them. So attempting first question, they say list two properties of heating elements. So two properties of heating elements are they have high resistance and high melting point. So resistance should be high, ज़्यादा resistance होना चाहिए because जितना ज़्यादा resistance उतना ज़्यादा heat, और melting point भी high होना चाहिए because ज़्यादा heat होगा तो melt नहीं होना चाहिए, अगर वो melt हो गया तो heating effect नहीं दे पाएगा. So main two properties are high resistance and high melting point. Now next, two properties of electric fuse. तो fuse में the very important point is the melting point should be low, because if the heat is exceeding it should melt. So low melting point. And next, out of this two you can write any two, that is the fuse should be a good conductor, so good conductivity, and it should have high resistivity. And in the third question, C, first they have asked us name the principle of which on which electric fuse works. So principle is heating effect of electric current, because as it gets heated up it melts. And how will it how a fuse wire is capable of saving electrical appliance? The same reason, when heat exceeds it melts and it saves the circuit. So you'll have to write brief 2 points about it: principle of heating effect, and then in the second point you'll have to write how the fuse will melt and save the circuit. Moving ahead, next one, they have asked us the power. Find the current flowing in the circuit. What will happen to the electric fuse? So similar question we have solved in the top. So we'll have to calculate the current. They have given us power and potential difference. Current is 5 ampere and the fuse used is also 5 ampere. So the fuse will not melt and the circuit remains safe. If the current will exceed than 5 ampere, then fuse will melt. So as our current is less than 5 or equal to 5, the fuse will remain safe. Now the last set, 31/2/3, so rest of the things were same, just the MCQ was different. In this they have asked to study the following statements, and out of the statements any two are correct. So statement A and statement C are correct, which says fuse in a circuit prevents damage to the circuit due to overloading. Yes, because if you overload, heat will increase and which will melt the fuse. Similarly, during short circuiting, the current in the circuit abruptly increases. Yes, the circuit is short, so the current will follow a short path, which will increase the heat and which will then melt the fuse. So like this we have covered maximum of the questions of previous year and tried to recall all the concepts. I've attached the PDF in the description where you can find out this question and their solutions, which would be helpful for your revision. I hope this video helps you and you rock tomorrow's paper. So all the best and aag laga do. Thank you.